Okay, so for this lesson, it was based off the Ferris wheel in Chicago, so I went ahead and looked that up. It's about 196 feet, has a diameter of 140 feet, which I converted into meters for the sake of the next step here. Then I guessed the height off the ground was about 56 feet because this minus this is 56. So I went ahead and used that for later things. So the current speed that they gave us, it's 1 minute 45 seconds for one revolution, which I calculate down here to be 4.34 miles per hour. So I calculated the velocity by 2 pi r over the time, so the circumference over the time, 2 pi times the radius in meters over the seconds that it took, and you can see how I calculated it there. So that's 4.34 miles per hour right now. It can only be 12 miles per hour, so I went ahead and put it at that, converted it to revolutions over time. So I went ahead and did 12 miles per hour equals 2 pi times the miles, which is the radius in miles. Did the calculations there to get the time of 37.9 seconds, or I just rounded it up to 38 seconds. Every revolution, it's about 12 miles per hour. I understand if I was a real engineer, it would have to be more precise, or we'd have to go a little bit slower, because even that would make a difference. So, but for this sake, I did not do that. So the height of the car at certain times, went ahead and did the unit circle type thing here. So wrote everything I knew over here. So started 56 feet off the ground, so at 0 seconds it's at 56 feet. Divided 38 seconds by 4. So over here at 9.5 seconds, it is the radius plus the 56, so 126 feet right here at 9.5. As it goes to 19.6, it's the total height, 196. Down to 28.5 seconds, we're back to the 126. And then back to 38 seconds, we're back down to the 56. So that is translated into a cosine graph here. All right, so same thing, 0 seconds, we're at 56 feet, 9.5 seconds, we're at 126. At 19 seconds, we're at 196. At 28.5 seconds, we're at back to 126, and then back to the 56. 126 ended up being our midline. So midline 126. So the amplitude, so 196 minus 126 is 70. And then 126 minus 56 is 70, so we know that the amplitude is 70. And because the graph is not starting like a regular cosine graph, it's going in the up direction, it is negative. So we know the period's about 38 seconds because it takes one revolution 38 seconds. And so that's the period, set it equal to the formula to find B, pi over 19. Then we find the phase shift is 126 because the midline is shifted up to 126 from 0. So now we can set up our equation to find the height at any one time throughout the circle. So that would be negative 70, the amplitude, cosine pi times t, which is the time, over 19, plus 126. So that's our formula. So we can find any type of height in any amount of time. Now, based on the graph, I mean, I don't think the problem really accounted for that 56 being off the ground or whatnot. So the camera being 20 feet off the ground is like somewhere down here. So really it needs to be like, I don't know, 3 seconds or so. Even quicker probably, so I just guessed 3 seconds, don't really know, and based on kind of what I was doing here, the water would work. So